So now the bottom line is this. To find the confidence interval for a population mean mu, we have to make the assumptions, one, that we have a simple random sample, two, a normal population or large. Notice this is an or. So if you have a large, remember large means 30 or larger, 30 or more, then you can relax the normality assumption. If you don't have a large, then you have to have a normal population. So either you have to assess normality, you know how to do that, probability plot. So you have to determine approximate normality. That's why I had, in that one slide earlier today, I had that probability plot up there, because we needed to check for normality. So to find a confidence interval level of 1 minus alpha, I'm not really quite sure I like the way this guy has this set up. But anyways, to find the confidence level, we do have to find the z alpha over 2 z-scores, because we know we're going to need that for right here. Second, we're also assuming sigma is given. So we have to know, right now we have to know the standard deviation of the population. We have to know that. If you don't, and this is large, it's okay, throw S in. If the sample is large, or you know it, you have a large, or you have a normal population, or large, if you know sigma, then you have to use it. If you don't know it, don't worry about it, because if you're large, throw S in, and you're okay. Now this is where there's a bunch of conditions coming up. All right. So basically what I want you to know right now is that if sigma is known or large, you use a z interval. That's what I want you to know right now. If sigma is known or you have a large sample, use a z interval. This is going to change when we come back on Thursday. So I'll say it just one more time. If the population is large, sigma known, use the z. I'll come back and give you a few more other conditions in a little bit. So then we can compute our confidence interval, which is right here. And then we have to interpret. Note, the confidence interval is exact for normal populations and is approximately correct for large samples from non-normal populations. Trust me, whether these intervals are exact, it's not going to make or break you. I mean, seriously, it's not. But you don't want to mess it up either. So if the population is normal, then this is exact. If the population is skewed away from normality, then these will be approximately correct. All right? And then one last slide before we actually get into some number crunching. Some popular confidence levels for you to use are the 95%, 90, 95, and 99% confidence. Notice that the 90% confidence level corresponds to an alpha level of what? Say again? A 90% confidence level corresponds to an alpha level of 0.1. Sound familiar? A 95% confidence level corresponds to an alpha level of 0.05. Sound familiar? A 99% confidence corresponds to an alpha level of Sound familiar? I asked you to pick an alpha level. Okay. The alpha over 2, notice the z-scores. Okay. If you're computing these, you might want to put these to memory So for a 90% confidence interval, it's 1.65. For a 95, 1.96. Notice the empirical rules said that approximately 2 standard deviations is approximately 95%. We can easily see now it's about 1.96 standard deviations away. Recall from the empirical rule we said after about 3 standard deviations, approximately 99.7%. Well, for a 99%, the actual value is 2.58 standard deviations. Okay. So we kind of mentioned these earlier in the term. All right, so I'd like to state how we're going to do these. I know that we said it on the other slide, but first we are going to choose the confidence level. All right, so once you have the confidence level 2, you can compute alpha equals 1 minus the confidence level. Step number 3 is you can compute alpha over 2. 4, determine z sub alpha over 2. And then finally 5, compute x bar plus or minus z alpha over 2 sigma over root n. So this is kind of the procedure you can kind of follow to compute confidence intervals. All right, so let's do these 5 steps and construct our confidence interval. A survey of 35 adults found that the mean age of a person's primary automobile is 7.3 years. Assume the standard deviation of the population is 0.97 year. Compute the 99% confidence interval of the mean of the population mean. So that is, of all people that own automobile cars, what's their average age? We don't know. Pull a sample of 95, and now we're going to construct a confidence interval, 99%. Okay? So let's do it. So step number 1 says to determine the confidence level. Well, we already know the confidence level. So we know that the confidence level is 0.99. Step number 2, compute alpha. So alpha is 1 minus 0.99, which is equal to 0.01. Step number 3, alpha over 2 is 0.01 divided by 2, which is equal to 0.005. Step number 4 is to determine z sub alpha over 2. So again, one thing you can do is use your normal curve and note that this area is 0.005 and that this area is 0.005. So if you have to use the book or your tables, you pull out your z tables, you go to 0.0005 in your table, and you will find that this is about negative 2.58, because this is one of the numbers I gave on that table, by the way, as well. And so this one here by symmetry must be 2.58. And we know that this confidence level is 0.99. See how it's all kind of adding up here and breaking apart and adding up? And so finally now, step number 5 is to compute the interval. So we know that x bar is 7.3 plus or minus 2.58, and we are given the standard deviation of 0.97 divided by the square root of n. N is 35, so this is the square root of 35. So I always compute mine, and remember when you report back confidence intervals, it's always lower bound, comma, upper bound. Please remember that. So I'll go 7.3 minus 2.58 times 0.97 divided by the square root of 35. Close, close. So that gives me 6.88. And now let me show you a shortcut. Rather than retyping the whole thing, the calculator keeps a history. Okay, so all I want to do is change that minus to a plus. So if I go second enter, that'll pull the previous step back up. And now all I got to do is arrow up to that and change the minus sign to a plus, and then press enter, and that gives me my upper bound. Might come in a little handy. Unless you like to retype all of this. That's fine, feel free. We'll let you. Okay. So our confidence interval then, 99% confidence interval is going to be 6.88 to 7.72. So you might want to watch the video to get this interpretation part, but I'll be saying it a few times. So we are 99% confident that the true mean age of people's primary automobiles is between 6.88 and 7.72 years. We are 99% confident that the true mean age of a person's primary automobile is between 6.88 and 7.72 years.